Hello, good morning, students. Okay, today we are going to see calculus. So this is first we will see the maximum and minimum topic. See the first problem. This is one of the gate question. As x is increased from minus infinity to infinity, the function f of x is equal to e power x by 1 plus e power x. See, we have to check whether this function is monotonically increase or monotonically decrease. Increase to maximum value, then the decrease, or decreases to minimum value and then increases. So what we have to find first of all, find the first derivative. So take f dash of x, differentiate the given function with respect to x. Now this is of the form, the function is of the form u by v. So e power x divided by 1 plus e power x. So apply the division rule, v into u dash minus uv dash by v square. Right? So v u dash, when you are differentiating this, v u dash minus u v dash by v square, right? So now the denominator is 1 plus e power x. Take this is 1 plus e power x is v. And what about u dash? Your u is equal to e power x. The differentiation of e power x is you will be getting same e power x. And then minus u into v dash. U is e power x. And again you are differentiating the denominator is we are getting e power x only divided by 1 plus e power x the whole square. After eliminating, finally we'll get e power x divided by 1 plus e power x the whole square. So you know that e power x takes always positive value in the interval minus infinity comma infinity. So therefore the numerator is always positive and the denominator is always positive. Therefore the first derivative is greater than or equal to 0. Whenever your first derivative is greater than or equal to 0, you can say the given function is monotonically increases. So to find the monotonically increases, the condition is the first derivative must be greater than 0. So it satisfies this condition. And come to second question. See, a function is given by f of t is equal to sine square t plus cos 2t. Which of the following is true? Okay, this is one gate question. Here the four option is given. F has frequency components at 0 and f has frequency components at 0 and 1 by pi. F has a frequency component at 1 by 2 pi and 1 by pi. F has the frequency components at 0, 1 by 2 pi and 1 by pi. So now take the given problem. The problem is f of t equal to sine square t plus cos 2t. Right? That cos 2t can be written as 1 minus 2 sine square t. After that, simplifying, you will get f of t is equal to cos square t. Okay, now clearly this function have 1 by 2 pi frequency components. And also, we can define like this also, that cos square t, write down the formula for sine square t. So what is sine square t formula? 1 minus cos 2t divided by 2 plus cos 2t. When you're simplifying this, 2 into cos 2t, 2 cos 2t minus cos 2t, you'll be getting 1 plus cos 2t divided by 2. And then, so what about the formula? The numerator formula 1 plus cos 2t. Yes, this is what cos square t, 2 cos square t, right? 2 cos square t divided by, already 2 is there, that 2 get cancelled, you'll be getting cos square t. And next, see the problem, limit theta tends to 0, sine theta by 2 divided by 2. You have to calculate this value, but we know on standard result. What about the result? Limit theta tends to 0, sine theta divided by theta. This is a known result, sine theta divided by theta. This value becomes equal to 1. Yes, but here we cannot use the result here because the theta is different. In the numerator and denominator must be theta value must be same. Here sine theta by 2, the denominator only theta is exists. So you have to rearrange the term. The denominator term, this theta becomes, or multiply and divide by 2 here. So you'll be getting what? The numerator is already sine theta by 2. Anyway, we cannot change any correction in the numerator. So we'll do only in the denominator. So write the denominator term, that theta can be written as theta by 2 into 2. Right? Now you apply the formula, apply the limit only for this term. So you know that sine theta by theta, whenever the term is like sine theta by theta, after applying the limit theta tends to 0, this value becomes 1. So 1 into 1 by 2. Yes. So the answer is 1 by 2. Here see the first option 0.5. Then see the next problem. Read this next problem. The following are the values of the function y of x. And y of minus 1 is equal to 5, y of 0 and y of 1 is equal to 8. These are the initial conditions given. And what we have to find out the first derivative dy by dx at the point x is equal to 0. So you have to use Newton's central difference formula. What about the Newton's central difference formula? This is the formula. Dy by dx is equal to dy by dx at the point initially x is equal to 0 equal to y2 minus y1 by x2 minus x1. So it's nothing but y2 is nothing but what? Y of x2. And what about the y1? So y1 is nothing but y of x1. Yes, the y of x1 can be written as y1. And the denominator term is 2 minus x1. This is the Newton's central difference formula. Here, take this is y of 1 is equal to 8. So you consider this x naught, that is y of 0. Here, this 0 can be taken as x0. So y of 0 is taken as x0 and y of 1. So y of 1 is taken as what? X1. So clearly x1 is equal to 1. So this is x1 is equal to 1. And x2 taken as x2 is equal to what? Minus 1. This is x2 is equal to minus 1. So y of 1 is equal to 8. That is y of x1 is equal to 8. And here y of minus 1 is given. You consider this minus 1 taken as what? X2. So y of x2 is equal to minus 1, 5. Y of minus 1 is equal to 5. So apply here y of x2 minus y of x1 divided by x2 minus y1. So what about x2 value? Here x2 is equal to, x2 is equal to 1 and y1, here x1 is equal to minus 1. So now this is y of x2 and this is y of x1 divided by x2 minus x1. So now apply here y of 1 is equal to 8 minus y of minus 1. What about y of minus 1? 5. And the denominator term is 3. Here minus 1 into minus 1 becomes plus 1. So 2. So 8 minus 5, 3. 8 by 2, 1.5. So this is the answer. You consider in any way. Here y of x2 minus y of x1. I am taking here not mentioned in way. So you consider this is x1, x2, or the first term is x2, the second term is x1. But in any way, the answer becomes same only. Here, the answer is what? 1.5. This is your answer. See, the option B is the correct. Then next, see, this is very repeated problem in GATE questions. Read the problem. If y is equal to x plus square root of x plus square root of x plus square root of x plus or minus, sorry, plus or plus etc. up to infinity. Then we have to calculate y of 2 value. So anyway, here clearly this y is greater than x. So now we'll try this problem. So what is the given problem? Y is equal to x plus square root of x plus square root of etc. Okay, now I'm taking this x into the left side. So we are getting y minus x. This is your left side value equal to x plus square root of x plus etc. up to infinity. When you're squaring on both sides, here the left side becomes y minus x the whole square. And what about your right side? Your right side is overall you are having one square root. This is overall square root. Here the inside the terms. Okay, here the first term is x and plus here x plus etc. Yes, when you are taking squaring on both sides, right? In the right side, when you're squaring on both sides, the square and this root becomes cancelled. So we'll get only x plus. So this is your answer, x plus square root of x plus etc. etc. up to infinity. Okay, so already in the left side you have what? Y. Already we keep one x in the left side. Okay, so here we have y minus x, y minus x. Here that root and square get cancelled. So we'll get one x plus and square root of x plus square root of x plus etc. up to infinity. Now clearly this minus x and plus x get cancelled. Okay. Or see the answer here. You have to calculate when I'm substituting x is equal to 2. You have to do y of 2 value. So don't cancel this x value. Okay. See now I'm writing this y of minus x, y minus x in the left side. At the right hand side, read the term. So what are the terms exist in the right side? X plus and square root of x plus etc. Square root of x plus. And now this is clearly, this is the given problem, no? X plus square root of x plus etc. This is your given problem. This is taken as y. Okay. So now I am taking this y minus x is equal to y. So clearly this is y minus x is equal to y. Y minus x is equal to y. Okay, then. But in left side you are squaring, no? After squaring, we'll get that root only cancelled. So now the left side becomes y minus x the whole square. So now this is what y minus x the whole square equal to right side is just y only. Okay, now expanders, this is of the form a minus b the whole square. So now expanded y minus x the whole square expanded. Yes, y square a square minus 2ab minus 2ab 2yx plus b square plus x square is equal to right side is y. Okay, now substitute x is equal to 2 because we have to calculate now y of 2. Y of 2 is nothing but what? Find y value whenever x is equal to 2. So now substitute wherever x exists, you replace x by 2, find out y value. So clearly after substituting x is equal to 2, we'll get y order value is either we are getting this like equation y square minus 5y plus 4 equal to 0. This is one quadratic equation. After simplifying this result, we are getting y minus 4 and y minus 1 is equal to 0. So we'll have two values, y is equal to 1 and y is equal to 4. But here y is greater than x. Y is greater than x. What about x value? X is equal to 2. So therefore that y takes more than 2 only. So herely y is equal to 4. So option, see here sixth option is B. Next, see this problem. The value of limit x tends to infinity sin x by x. So already we've seen the same problem. This is the direct problem. Limit x tends to theta tends to but the previous problem we have seen what a limit theta tends to 0. Yes. See the previous problem. Yes, the fourth problem is a limit theta tends to 0 sin theta by theta. Limit theta tends to 0 sin theta by theta is equal to 1. Here the same problem but limit only different. Limit x tends to infinity sin theta divided by theta or sin x by x. So now in this problem, you have to, if you are substituting x tends to infinity here, you will be getting infinity by infinity, you will be getting indeterminate form. So whenever the limit x tends to infinity is given, in the given problem, you have to replace all the variables by inverse term. Like x is equal to, here x is given, you replace that x by 1 by z. So in the given problem, you replace all x by 1 by z. So after that, the problem becomes limit x tends to infinity sin x by x is equal to a limit. Now I'm replacing this x by z or y. Okay, so or if you're taking this as 1 by y, whenever x tends to infinity means x tends to infinity means if I am replacing this x is equal to 1 by y, what about y value? So y is equal to 1 by x. So now substitute x tends to infinity here. When x tends to infinity becomes what? Here y tends to 0 because y is equal to 1 by x. So when I'm substituting x tends to infinity in this problem, y is equal to 1 by x, your y goes tends to 0. So now here in the instead of x tends to infinity, you replace y tends to 0. The same time that sin x, you replace all x in terms of y. So sin of your x is equal to 1 by y. This is x value. So replace here sin x by x is 1 by y by y. Now apply the same formula. So already told the formula, limit theta tends to 0, sin theta divided by theta equal to 1. Here sin y by y, 1 by y divided by 1 by y equal to 1. So the answer is same. So therefore the value of limit x tends to or theta tends to 0, sin theta by theta, and also limit x tends to infinity, sin x by x, the value is 1. In the next, see this also very important problem. The value of limit x tends to infinity. Limit x tends to infinity, 1 by sin x minus 1 by tan x. So first of all, we will simplify before substituting limit tends to infinity. We will simplify the result, and here this will becomes what? 1 minus sin x by 1 by sin x into 1 by tan x. Now the first term is same, 1 by sin x, 1 by sin x. This is the first term minus. In the second term, the tan x becomes, right, tan x as sin x by cos x. Okay, the denominator is same. So the answer is what? 1 minus cos x. 1 minus cos x divided by the denominator is sin x. Now 1 minus sin cos x can be written as a trigonometric formula. So 1 minus cos x can be written as 2 sin square x by 2. Because 1 minus cos 2x divided by 2. What about sin square x? Sin square x equal to, sin square x is equal to 1 minus cos 2x divided by 2. So now 2 sin square x is equal to 2 sin square x is equal to 1 minus cos 2x. Okay, so here this 1 minus cos x, here 2 is not there, so 1 minus cos x, so divided by 2, so this x becomes x by 2. Therefore 2 sin square x by 2, nothing but 1 minus cos x. So here the left side is 2 sin square x by 2. So now this is your numerator term, 1 minus cos x becomes 2 sin square x by 2. Same time the denominator, see here you have to write the denominator is also in terms of sin x by 2. Now apply the formula, sin 2a formula. What about sin 2a formula? You can write sin 2a is equal to, what about sin 2a formula? 2a into cos a. This is sin 2a formula. So divided by 2 the angle. So we'll be getting sin a equal to and 2 sin a by 2, 2 sin a by 2 into cos a by 2. So now here apply the sign for sin x. Instead of sin x, you replace 2 sin x by 2 into cos x by 2. Now clearly this 2 get cancelled, and sin x by 2 and sin square power cancel. You are getting finally sin x by 2 by cos x by 2. You know that sin theta by cos theta is equal to tan theta, so tan x by 2. Now we are applying limit x tends to infinity here. We'll get tan infinity. So you know that tan infinity becomes infinity. You can find for infinity tan value. So tan of infinity equal to infinity. So now the answer is P for 8, the answer is D is equal to infinity. Then next, see this problem, the function f of x is equal to modulus of x plus 1 on the interval minus 2 comma 0. Here there are 4 options given, continuous and differentiable, continuous on the integral but not differentiable. So that is, it is only continuous, not differentiable at all the points. And third option is neither continuous nor differentiable. The fourth is a differentiable but not continuous. So now let's take the given problem, f of x is equal to modulus of x plus 1. So now this function is clearly continuous. Clearly the function is continuous at the interval minus 2 comma 0. Now draw, this is the graph for modulus of x plus 1. We know that modulus of x plus 1, you can define any modulus value. Yes, what is the definition? How will you define the modulus function? So now modulus of f of x takes the two values. So that is modulus of f of x is equal to x whenever x is greater than or equal to 0. So and f of x takes the negative values minus x whenever your x is less than 0. Yes, you can define f of x whenever modulus form is given for f of x. You can define this f of x is equal to x and f of x is equal to minus x. Okay, now clearly the functions is continuous. Mark the point minus 2 comma 0 here in the graph. Just draw the point, draw the graph and take down the points minus 2, minus 1, 0. These are the given, yes, in the real axis. So now this is minus infinity comma infinity, this is x axis. In x axis take 0, 1, 2, 3, here minus 1, 2, 3. And whenever x is greater than or equal to 0, or put x equal to 0 here, whenever x or value is 0, what about y value? X is equal to 0 means y value is equal to 1. So corresponding x is equal to 0 here, x is equal to 0, y equal to 1. Okay, this point. And x is equal to next point. What are here? X is greater than or equal to 0 means x takes what are the values? X takes the values is 0 and 1, 2, 3. These are the x values. This is for x greater than or equal to 0. So if x is less than 0, then x takes the values is what? And minus 1, minus 2, etc. These are the values for x whenever x is negative. So now draw the graph for the corresponding points. When x is equal to 0, substitute here x is equal to 0. But this is the general definition, f of x is equal to, this is for the definition for f of x is equal to modulus of x. But here the function is f of x is equal to, the given problem is modulus of x plus 1. So modulus of x plus 1, it takes, first one is x plus 1 whenever x is greater than or equal to 0. And second one is minus of x plus 1. Minus of x plus 1. Right? Here this is x greater than 0 and this is x less than 0. For second one, x is less than 0. Right? Now I'm substituting x greater than or equal to, first of all put x is equal to 0, we'll be getting value is 1. After the corresponding point, the first point is what? 0, 1. And mark the point 0, 1. Here this is the place 0, 1. And then put x is equal to 1. Here x is equal to 1. Substitute x is equal to 1, y is equal to 2. Yes, here x is equal to this point is 1, 2. Right? And this is what? 0, this point is 0, 1. Okay, next. So x is equal to 3, 1, 2, x is equal to 2, and this point becomes x is equal to 2, this is 2, 3, right? And 3, 4. You can extend. Next, if x is less than 0, and less than 0, no, the nearest point is next point for 0, put x is equal to minus 1. So x is equal to minus 1 means we are substituting x is equal to minus 1 here, minus 1 plus 1 becomes 0. So x is equal to minus 1, x is equal to minus 1, and your y value is 0. And then x is equal to minus 2 plus 1 equal to minus 1, and minus of minus 1 plus 1. So x is equal to minus 2, y is equal to plus 1. Yes. Then draw x is equal to minus 1. This is x is equal to minus 1 and y is equal to 0. And then x is equal to minus 2, y is equal to 1 here, this point. Yes. Clearly x is equal to minus 3 and drop the point. Yes. Now join the lines. Okay. Now here there is no break. So clearly this function f is continuous at minus 2 comma. Here there is no break. There is no discontinuous exists. Therefore f is continuous at minus 2 comma 0. Okay. And anyway, it is not differentiable at x is equal to minus 1 because we can draw the infinite number of the tangents at x is equal to minus 1. So in that place x is equal to minus 1, you can draw many infinite number of tangents. That's why it is not differentiable. See the next problem. Limit x tends to infinity. Limit x tends to infinity. X cube minus cos x by x square plus sin x the whole square is equal to. So we have to find the limit for this function x cube minus cos x by x square plus sin x the whole square. Here, and clearly this sin x and cos x finite value, whatever x may be. Yes, if you are substituting any value and sin x and cos x are finite only. Now, x cube, consider only x cube, the first term only you are considering x cube by x square. Because the sine and trigonometric terms take only the finite. Whatever the values you are giving x, you are getting just finite value. You consider the remaining term only x cube by x square, right? What about x cube by x square? If you are eliminating this x square and x cube 1x, finally you have just x only. After substituting x tends to infinity, you are getting answer is infinity. Okay, see where it is infinity exists, the option is the correct answer. And next term, see the problem. It's also a great question. If y is equal to modulus of x for x is less than 0 and y is equal to x, y is equal to modulus of x for x is less than 0 and the y would value equal to x for x is greater than or equal to 0. Then here there are 4 options given. dy by dx is discontinuous at x is equal to 0 and y is continuous at x is equal to 0, discontinuous at x is equal to 0. Y is not defined at x is equal to 0. Both y and dyx discontinuous at x is equal to 0. So there are 4 options. So y is not defined. This is wrong because you can define that x is equal to 0. At x is equal to 0, y would have value equal to x. So this is wrong only, right? And clearly this y is discontinuous. Dy by dx is discontinuous at x is equal to 0. This is the first option. See the second option is y is discontinuous at x is equal to 0. Yes, because at the point x is equal to 0, we are getting different values. So therefore, at x is equal to 0, because y is equal to modulus x in both x takes 2 values. You can define like modulus x means what? X takes 2 types of values, x and minus x. Whenever x is greater than or equal to 0 and x is less than 0, but x greater than or equal to 0, we are getting 2 different values. Therefore, y is discontinuous at x is equal to 0. In the next term, limit x tends to 1, x square minus 1 by x minus 1. How to calculate this? Limit x tends to 1, x square minus 1, x minus 1. So here, we'll apply the 2 rules. When I'm substituting directly x tends to 1 here, what will we get? X tends to 1. So 1 square minus 1, we'll get 1 minus 1, 0. And the denominator is, when I'm substituting x tends to 1, 1 minus 1, 0. So we are getting indeterminate form. So whenever indeterminate form exists, you can apply the L'Hospital rule. So differentiate numerator and denominator separately. So what about the differentiation value of the numerator? So x square differentiation value is 2x and 1 of the differentiation is 0 and denominator is x of the differentiation is 1. Now apply the limit tends to 1 here. After applying x tends to 1 here, so we get 2. 2 by 1, 2. So this is the answer to R. Without applying L'Hospital rule, you can just simplify the result first, then apply the limit. Now, numerator terms becomes a square minus b square 4. You can apply the formula a plus b into a minus b. So now this x square minus 1 becomes x plus 1 into x minus 1. The a plus 1 a minus b. A plus b into a minus b. The denominator is a minus b. And x minus 1 get cancelled. We are getting x plus 1. Now apply the limit x tends to 1 here. X tends to 1. So you're getting 1 plus 1 is equal to 2. And then next. What is the derivative of f of x is equal to modulus of x at x is equal to 0? What is the derivative of f of x is equal to modulus of x? So you can differentiate directly if f of x is equal to x. F of x equal to x means you can differentiate directly f dash of x is equal to 1. F of x is equal to of x. F of x is equal to modulus of x. You cannot differentiate because you will define in two way. X takes the two different value. This is the graph for y is equal to modulus of x. This is the graph y equal to modulus of x, because whenever x is greater than or equal to 0, y equal to x. So y equal to x means a straight line passing through the origin in the first quadrant. It lies on the first quadrant. And now this line denotes y is equal to minus x. Okay, now at x is equal to 0, here in that point you can draw infinitely many tangents, and so the limit does not exist. The particular point x is equal to 0, that is the origin, we can draw infinitely many tangents. Whenever you can draw the infinitely many tangents means the limit does not exist. The limit does not exist means the derivative. The problem is at the derivative exists or not. So does not exist. The derivative does not exist at the particular point. Next, which of the following functions, so we'll go for next one, which of the following function is not differentiable in the domain minus 1, 1? Here some few functions is given. First one is f of x is equal to x square, and f of x is equal to x minus 1, f of x is equal to 2, f of x is equal to maximum, and the point x comma minus x. So which one is not differentiable? Yes, clearly f of x is equal to x square. This is not differentiable in the domain minus 1, 1. And next, see limit x tends to 0, sine square by x is equal to, yes, we cannot find the limit directly here, because we know only the formula limit theta tends to 0, sine theta by theta. Here the numerator only square exists. Then what we have to do? Yes, the problem is a limit theta tends to 0 and a sine theta by theta. Limit theta tends to 0, sine theta by theta equal to 1. But here the numerator is square term exists, sine square. So anyway, you have to make the denominator also square. But here the denominator only x. Numerator is sine square x. The denominator term is only x. So what we have to do? Multiply and divide by x. Just multiply and divide by x. Here, when I am multiplying x, you will get x into x, x square. In the numerator also, you have to multiply by x. So what will you get? Yes, limit x tends to 0, sine square x by x square. Here 1x. Okay, now I'm writing the sine square x by x square becomes sine x by x the whole square into x. Now apply the limit by term. For the first term, when I applying theta tends to 0, sine theta by theta,
For the first term, sine theta by theta equal to 1. So 1 square is equal to 1. And limit x tends to 0 for x. X tends to 0, sine x is equal to 0. So 0 into 1 becomes 1. And come to the next problem. So f of x is equal to 2x square minus 7x plus 3 divided by 5x square minus 12x minus 9. Apply the limit x tends to 3 for the function f of x. Limit x tends to 3. Now, when I'm substituting directly, we cannot cancel any term here because there is no common term. Okay, you can directly substitute x tends to 3. 2 into here 3 square. Yes, 2 into 3 square is 9 minus 7 3s are 21 plus 3. This is the numerator term. And for the denominator, substitute 5 into and 3 square 9 minus 12 into 2 3 36 minus 9. Yes, you simplified this. 3 divided by 45 minus 36 minus 9 becomes 45. So 18 plus 3 21. So the numerator becomes 21 minus 21 is 0. And the denominator is also 0. You are getting indeterminate form, 0 by 0 form. So whenever you are getting indeterminate form, what we have to do? Differentiate numerator and denominator separately. That is, we have to apply the L-Hospital rule for this. And what to put the differentiation value of the numerator? Yes, 4x minus 7. And the denominator is 10x minus 12. Now apply the limit x tends to 3 here. 3 4s are 12 minus 7. And here x tends to 3. 10 into 3, 13 minus 13. So 12 minus 7, 5. 7 is 12 only, no? Next minus 12. So now this is 12, not 13. This is 12. 30 minus 12. So you're getting 18. So 5 by 18. 5 by 18. See, where's the option 5 by 18? C. 5 by 18. That is B only correct. Then next, see this. Limit x tends to 0. E power x minus 1 plus x square divided by 2 by x cube. Here, if you are substituting directly x tends to 0, you are getting infinity, no? E power 0 becomes 1. No? And I'm substituting x tends to 0 directly. E power x becomes 1. And then this is what? Minus 1. And after substituting x tends to 0, this is minus 0. And 0 by anything 0. Right? And x tends to 0 means the denominator is 0. Denominator is 0. And 1 minus 1, 0. So we are getting 0 by 0 form. So what we have to do whenever you are getting 0 by 0 form? Differentiate numerator and denominator separately. E power x order derivative value is 1 minus 1 order differentiation is 0 minus x order differentiation is 1 plus x square order differentiation is 2x by 2 and 2 get cancelled. I am substituting x tends to 0. Again e power 0 1 and 1 minus 1 0 by denominator x tends to 0 3 into 0 0. So again we are having 0 by 0 form in determinant form. And again apply the same rule, differentiate numerator and denominator separately. E power x order derivative value is e power x minus 1 order differentiation 0 and x order differentiation value is 1 divided by, and this is not plus 1 and this is minus 1 because this minus is common to all, and 3x square differentiation value is 6x. 6x again you are getting, after applying the limit x tends to 0, we are getting 0 by 0 form, indeterminate form. So apply the limit e power, again the apply the L'Hospital rule, e power x by 6. The differentiation value of 6x becomes 6. So now I'm substituting x tends to 0, we are getting e power 0 is 1, so 1 by 6. The option is B. Next, find the value of limit x tends to 8, x power 1 by 3 minus 2 divided by x minus 2. Find the value of limit x tends to 8, x power 1 by 3 minus 2 divided by x minus 2. The option is 1 by 16, 1 by 12, 1 by 8, 1 by 4. Okay. Here, if you are substituting directly 8, so now if you are substituting directly 8 here, what will you get? We are substituting the limit numerator and denominator. So after substituting the limit x tends to 8, the terms becomes 8 power 1 by 3 minus 2 by 8 minus 8 is 0. And clearly the denominator term is 0. What about the numerator? The 8 power 1 by 3 becomes 2 power 3. The 8 can be written as 2 power 3. 2 power 3 is 8. And 4 whole power 1 by 3. 2 power 3 whole power 1 by 3. The 3 get cancelled 1 by 3. Right? The power 1 by 3. Power 1 by 3. And by 2. By minus 2 is 2. So now 2 power, yes, here power is 1 by 3, no? This is not 1 by 2, this is 1 by 3. So now this 3 and this 3 get cancelled. This 3 get cancelled. So we are having 2 minus 2. The numerator is 0 and the denominator directly we are substituting x tends to 8. The denominator is already 0. So we are getting 0 by 0 form. So whenever 0 by 0 form, we are getting 0 by 0 form, what we have to do? Apply the L'Hospital rule. So differentiate numerator and denominator separately. So what is the answer? By L'Hospital rule, differentiation of the numerator is 1 by 3, x power 1 by 3 minus 1 by 3 minus 1. The denominator is 1 by 3 is x power 1 by 3 to the power of 1 into 3, 3. 1 into 3, 1 minus 3 minus 2 by 3. This is your numerator and the denominator is, when you are differentiating this x order derivative value is 1. 8 1 is 0. Now you are applying the limit x tends to 2. Now this can be written as 1 by 3 into x to the power of 2 by 3. Now this is 1 divided by, now apply the limit x tends to what? 8. So now this is 3 and this is 8. 8 power 2 by 3. 8 power and 2 by 3. So 1 divided by 3 into that 8 becomes what? 2 cube into 2 power 3. Then 3 get cancelled. 2 square 4. 2 square is 4. Yes, and 4 into 3, 12. So 1 by 12 only the correct answer. Then next, function y is equal to 2 minus 3x is continuous for all x belongs to R and differentiable for all x belongs to R. For this function y is equal to 2 minus x, here there are 4 options given. The given function y is continuous and differentiable. And it is continuous differentiable except the point x is equal to 3 by 2. It is differentiable for all x belongs to R and x is equal to 2 by 3. It is differentiable for all x belongs to R except at x is equal to 3 and differentiable for all x belongs to R. So for this problem, the answer is C. So next, what should be the value of the lambda such that the function defined below continuous at x is equal to pi by 2? If it is continuous, the condition is given, the function is continuous at x at particular point. If it is continuous, then find out the lambda value. So now write the function. Here the function is given f of x is equal to lambda into cos x divided by pi by 2 minus x. If x is not equal to pi by 2 and f of x is equal to 1 if x is equal to pi by 2. So now write what is the continuous condition? What is the definition of the continuous? Limit x tends to a, f of x is equal to f of a. This is the definition of the continuous. Limit x tends to a, f of x equal to f of a. So now here a is equal to, the point a is equal to pi by 2. So now write limit x tends to pi by 2, f of x is equal to f of, take the point a is equal to pi by 2. So now find out limit x tends to pi by 2. So what about f of x value? Lambda cos x by pi by 2 minus x equal to f of pi by 2. So by the definition, the right side is f of a. So instead of a, substitute x is equal to pi by 2, f of pi by 2. Here the value is given directly, f of pi by 2 is equal to 1. Now substitute x is equal to pi by 2. Okay, now limit x tends to pi by 2, lambda cos x equal to 1 only given. When I am substituting x tends to pi by 2 here, what will you get? X tends to pi by 2, you know, clearly cos 90 is equal to 0. And the denominator term is pi by 2 minus pi by 2. That is 90 minus 90 is 0. So you are getting 0 by 0 form. So using L'Hospital rule, differentiate the numerator. So lambda cos x, so the differentiation is minus sin x. And the denominator term, the differentiation is pi by 2 minus here pi by 2 or the differentiation pi by 2 is constant. The differentiation of pi by 2 is equal to 0 and minus x, so the derivative value is minus 1. Now apply the limit x tends to pi by 2 here. Sine of pi by 2 is equal to 1. That minus minus get cancelled. The answer is lambda. So clearly for 27 problem, the answer is what should be the value of lambda such that the function defined below is continuous at x is equal to pi by 2. The answer is lambda is equal to not 1. Lambda is equal to 1. Okay, this is the point x is equal to pi by 2 is a given point. The lambda value clearly equal to 1. Next, given the one root of the equation is given. So the equation is what? X cube minus 10x square plus 31x minus 30 equal to 0. This is one cubic equation is given. So anyway, cubic equation means this equation has 3 roots. Okay, among 3 roots, the one of the root is given 5. What is the question? You have to calculate other two roots. So totally we have the three roots. Take the two roots, find out the third root. So clearly the root is given, no, 5. 5 is one root is given. So this is cubic equation. Write down using the synthetic division. You can use the synthetic division here. 1 minus 10 and 31 minus 30. Okay. And here clearly one of the root is given. So which is given, 5 is given, 5 is the root. And find out remaining two roots. 1 into 5, 5. And this is minus 5. And this is minus 25. And this is 6. 5, 6 are 30. And plus 30 minus 30 is 0. So after that, the equation becomes quadratic equation. The equation becomes x square minus 5x and plus 6. Okay, you can easily simplify this. And what is the roots? So 3 2s are 6 and minus 3 and minus 2. What about the roots? X minus 3, x minus 2 equal to 0. Then clearly x is equal to 3 and x is equal to 2. This is the roots, yes. And what is the answer for this? A. Okay. So now I use the synthetic division. This is the another method. Whenever one factor is given, can use this method also. But anyway, this is very easy using the simplex method. Right. Then next, see the value of the function f of x is equal to x tends to 0, x cube plus x square divided by 2x cube minus 7x square. Yes, if you are substituting x tends to 0 directly, so you'll get what? 0 by 0 form. So by L'Hospital rule, the answer is 3x square plus 2x by, this is what, 2, 3 2s are 6x square minus 14x. Again, you are getting 0 by 0 form. Again, apply the L'Hospital rule. 6x differentiated numerator 6x plus 2 and the denominator is 12x minus 14. And when I'm applying the L'Hospital rule, the answer is what? This is x cube, no, 3x square and differentiation is 2x. And this is 3 2s are 6, 2s are 6x square minus 7 2s are 14. And then apply this again. This is 14 only, no, 14. Okay, when I'm substituting the limit x tends to 0, here 6 into 0, 0 plus 2. And this is 2 by minus 14. The answer is 2 by minus 14. When I'm simplifying this, you get 1 by minus 7. So the answer is B. And then next, see this problem. Limit x tends to 0, sine of 2 by 3 into x by x. So clearly, you know, sine limit theta tends to 0, sine theta by theta equal to 1, right? Limit theta tends to 0, sine theta by theta equal to 1. So the answer theta must be equal. Here sine theta, yes. Here instead of this angle, we cannot any modify the term. So now this 2 by 3, this is the angle 2 by 3 into x. But in the denominator only x exists. So what we have to do, multiply 2 by 3 and here divide on. Okay, so multiply and divide 2 by 3. So now the answer for this sine, this is of the form sine. If you this 2 by 3 into x is, if you consider this is theta, then terms become sine theta by theta. So after applying the limit theta tends to 0, sine theta by theta is equal to 1. So already you are multiplied 1 2 by 3. So the answer is 1 into 2 by 3. Answer is 2 by 3. The same problem already we have seen. If y is equal to x plus square root of x plus etc. What about the answer? The 4 only. Yes, already we have seen the same problem. How will you do this? This is y minus x. Keep this x, the right side x, take it to the left side. Y minus x is equal to square root of x plus etc. Yes. Now, when you're squaring on both sides, this becomes y minus x the whole square. And what about this? When you squaring on this side, and square and root get cancelled, we'll get just x plus and square root of x plus square root of x plus etc. So now see this is already the given problem, no? X plus, this is a given problem. So the answer is y. So this is y. So when you expand it, this is of the form a minus b the whole square. If we expand it, a square plus b square plus 2ab minus 2ab equal to y. And again, what we have to do, substitute x tends to 2. Wherever x exists in that equation, replace x is equal to 2. We'll find y value, and you can easily identify the y is equal to 4. Then next, consider the function f of x is equal to modulus of x cube, where x is equal to real. The function f of x at x is equal to 0. So here there are 4 options given: continuous but not differentiable, once differentiable but not twice, differentiable, twice differentiable but not thrice, and thrice differentiable. The answer is A. This is continuous. So clearly, whenever modulus function is in the modulus form, the function must be continuous and not differentiable. Yes. And limit theta tends to 0, sine theta by theta is equal to 1. And see the expression e power minus ln x for x is greater than or equal to 0. So now this is minus ln x can be written as e power ln of 1 by x, and e power ln get cancelled. The answer is 1 by x. See, where is 1 by x? This is x power minus 1. This is the answer, right? So clearly this e to the power of, see now you take this is e power minus log x, right? E power minus log x, right? So now this is what? E to the power of a log of, and this is of the form n log m, that x power, take this minus into the power x to the power of minus, and you know e power log of value is 1. Final answer is x power minus 1. Okay, thank you, student. The next section we will continue. Right. Thank you.